Let's continue. Okay, our last method under analytical method is the what we call component method. Component method is the use of the x and y components of a vector in determining the sum of a given set of vectors. In using the component method, the resultant of a given set of vectors has a magnitude given by A sub r, or resultant vector, equals the square root of summation of x component quantity squared plus summation of y component quantity squared. The direction of the resultant vector is given by angle theta equals arctangent of summation of y component of the vectors divided by the summation of x component of the vectors. So let's have example problem number 5. 4 tugboats are on site to position a Norwegian cruise ship along the coast of Florida, exerting the following amounts of forces: 15 newtons 25 degrees north of east, 35 newtons 60 degrees west of north, 16 newtons 80 degrees north of west, and 100 newtons 10 degrees east of north respectively. Determine the resultant force on the ship. So given in the problem are as follows. F sub 1, 15 newtons 25 degrees north of east. F sub 2, 35 newtons 60 degrees west of north. F sub 3, 60 newtons 80 degrees north of west. And F sub 4, 100 newtons 10 degrees east of north, arranged chronologically as mentioned in the problem. Required was the resultant force acting on the cruise ship. Shall we say we use the scale of 1 centimeter equals 10 newtons? Let's now draw our direction guides. Our first arrow would be 5 centimeters in length, pointing 25 degrees north of east, as shown by this green arrow. At the tip of our first vector, we will draw another direction guide. By the way, this is 25 newtons north of east. So we need to have another direction guide here so that you will be placing your protractor over here to measure another 60 degrees west of north. So this would be 3.5 centimeters in length. So if this is 60 degrees west of north, so from the northern direction rather, you are to measure 60 degrees going west. At the tip of our second arrow, we will draw another direction guide and then put our protractor over this symbol here or over this guide for us to measure another angle, and that would be 18 newtons north of west. So 80 newtons north of west is measured from the western direction going northward. So this is 80 newtons north of west. And from the tip of our third arrow, we will draw again another direction guide, and we will be placing our protractor again over this direction guide to measure 10 degrees east of north, which means from the northern direction, you are going to measure 10 degrees going eastward. And our resultant force is represented by this single arrow in broken red arrow drawn from the tail of our first arrow to the tip of our last vector arrow. Let us be reminded that when we say component method, we need to determine the x and y components of our vectors here, get the sum of the summation of f sub x, or the summation of the x component of our forces, then we need to get the sum also of the y component of our forces in order to determine mathematically our resultant force F sub r. So let's have a look at how it is done in the following slide. Okay, so these are the given quantities. Now we need to construct a table. So this table shows the x and y component of our forces. So our force number 1 is 50 newtons, 25 degrees north of east. So if we are to take a look at this diagram, north of east means from here going here is simply 25 degrees. So in our table, angle theta for F sub 1 is 25 degrees. Next, let's have a look at F sub 2, 35 newtons, 60 degrees west of north. So this is 60 newtons, 80 degrees west of north. That means 90 plus 80 north. Okay, let's continue. F sub 2, by the way, is 60 newtons west of north, therefore 90 degrees. Okay, that means 90 degrees plus 90 degrees, 90 degrees plus 60 degrees will give us angle theta of 150 degrees. For F sub 3, which is 60 newtons, 80 degrees north of west. Let's go back to our diagram, our third arrow. This is 80 degrees, means 90 degrees plus 10 degrees, it's equivalent to 100 degrees. So our angle theta is 100 degrees. And for our last arrow of 100 newtons, 10 degrees east of north, let's take a look at the diagram. 10 degrees east of north, which means 90 minus 10, this is simply 80 degrees. So our angle theta for force number 4 is 80 degrees. Okay, 80 degrees measured from the positive x-axis. Now we are ready to find our x component. So our x component would simply be F sub 1 of 50 newtons cosine of 25 degrees will give you F sub 1x equals 45.32 newtons. X component of 35 newtons cosine of 150 degrees, F sub 2x equals negative 30.31 newtons. F sub x or x component of F sub 3 is 60 newtons times cosine of 100 degrees. That would be F sub 3x equals negative 10.42 newtons. Our x component for 100 newtons cosine of 80 degrees, F sub 4x equals positive 17.36 newtons. Getting the sum of all these values, the summation of our x component or summation of F sub x is equal to 21.95 newtons. So when we say summation, you add up. That's 45.32 newtons minus 30.31 newtons minus 10.42 newtons plus 17.36 newtons will give you 21.95 newton. Now for our y components, we do 50 newtons sine of 25 degrees. We get F sub 1y equals 21.13 newtons. Next, 35 newtons sine of 150 degrees. We get F sub 2y equals 17.50 newtons. Next, 60 newtons times sine of 100 degrees. That's F sub 3y equals 59.09 newtons. And 100 newtons sine of 80 degrees, you will get F sub 4y equals 98.48 newtons. Now, let's add up our y components, and that will give you summation of F sub y equals 196.20 newtons. So these values are essential in finding for our F sub r. Okay, let's continue. So here's the diagram we had earlier. Now, to solve for our F sub r, again, to solve for our F sub r, we have to consider the summation of our f of x and summation of f sub y as shown in these calculations. So our formula now to find our resultant force is simply equal to the square root of summation of f sub x quantity squared plus the summation of y component f sub y quantity squared. Substitute the values. That's the square root of 21.95 newtons squared plus 196.20 newtons squared. The result would be resultant force is equal to 197.42 newtons. To determine our angle theta, this angle, the angle formed by our resultant force with respect to the positive x-axis would be angle theta equals arc tangent of summation of f sub y divided by summation of f sub x. Then arc tangent of 196.20 newtons divided by 21.95 newtons will give us angle theta of 83.62 degrees. Okay, let's continue. Therefore, to summarize, our resultant force would be written as 197.42 newtons, 83.62 degrees north of east. Okay, therefore, this angle is 83.62 degrees, and the length of this arrow denotes 197.42 newtons, 83.62 degrees north of east. Okay, so in finding for the direction of our resultant vector, we always look for the nearest x-axis. So for this case, our summation of f sub x is actually lying on the positive x-axis, and our summation of f sub y is actually lying across the positive y-axis. So therefore, our direction here will be north of east, since the projection of the vector is along the first quadrant or along the northeastern direction. So just for comparison, earlier I have given this example in number 4. The direction of our resultant force is 56.31 degrees south of west. This time, our resultant force is projected along the negative x-axis and the negative y-axis, and look for the immediate x-axis near to the resultant arrow. Therefore, starting from the negative x-axis, we go southwards. Therefore, this direction is pointed 56.31 degrees south of west. So the most crucial part in denoting or expressing our directions here is looking for the nearest x-axis. Is that from the eastern direction or is that from the western direction? Going southwards or going northwards? Eastern direction going northwards or going southwards? So feel free to ask questions in our succeeding class if you have any confusion from pointing directions of our resultant vectors. So what I like about component method is you can have several vectors here, but you need to find for angle theta as measured from the positive x-axis going counterclockwise. Most probably this is the most crucial part here. The moment you get wrong angle thetas in this column, all the rest of these magnitudes will be wrong. So for me, the simplest method of adding vectors is the use of component method. So I just don't know with you, but for me, I am more comfortable with component method, since you simply have to make a list of your vectors, find the x component, y component, get the sum, and perform the needed procedures, needed operation as follows, and that will lead you to our resultant vector. So hopefully you learned something from this video presentation, and I would like to thank everybody for watching. Kindly comment your name just to tell me you were able to watch the video, as I will be posting this in my YouTube account. So again, I wish everyone good luck for the succeeding lesson. And I will see you all next meeting. Goodbye, everyone.